Okay, so this is question 3 of the week 2 sprint questions, and it says if the diameter of a circle is multiplied by 4, the area of the new circle is how many times that of the original circle? So there's actually a trick for this, which I'll show you guys, but first I want to show you how could you approach this if you didn't know the trick. Well, first we know if the diameter of a circle is multiplied by 4. It doesn't specify a certain diameter. We can pick any diameter. So let's say the diameter is 4. That means, of course, the radius, which is half a diameter, that's going to be 2. And this is our first circle. This is circle number 1. Circle number 2, the diameter, remember, is going to be 4 times that. The diameter is going to be 16, which means our radius is going to be half of that, which is 8. And so the area of a circle, remember, is pi r squared, where r is the radius. And so the area of circle number 1 is going to be pi times 2 squared, which is equal to 4 pi. The area of circle number 2 is going to be pi times 8 squared, which is going to be equal to 64 pi. Well, the area of this circle, the second circle, is how many times the area of the original circle? Well, 4 times 16 is equal to 64. So the area of the second circle is 16 times the area of the first circle. Do you notice anything interesting about that? Well, the diameter was multiplied by 4, and the area was multiplied by 16, which is 4 squared. And that is actually the relationship between all of this. So yeah, the answer is 16. And this is a totally valid way to solve the question, but if you want to know a little trick for it, I'm going to show you that right now. So let's think of our basic shapes in 3 dimensions, right? We have our one-dimensional figures, and that would be your sides, your edges, anything one-dimensional, a line. And then we have our two-dimensional figures, and that would be your polygons, circles, squares, triangles, any face of a 3-dimensional figure. And then we have our 3-dimensional figures, and those are just your rectangular prisms and such. We're really talking about a volume when it comes to 3 dimensions. So let's say you have a shape and it's a 3-dimensional shape and you scale the side length up by a factor of n. Well, by doing that, you're scaling the area up by a factor of n squared because side length is 1-dimensional, but area is 2-dimensional. And then you're scaling the volume by a factor of n cubed because volume is 3-dimensional. So let's say we have, let me give you the example of a cube. This is my beautiful cube, very well drawn. I spent a lot of time and effort on it, as you can clearly see. And how n is 2? We're scaling all of these edges by a factor of 2. The edges are twice as big. So all the edges are going to be scaled up by a factor of 2. And that means all the side lengths are going to be scaled up by a factor of 4. So the area of each face, the surface area is going to be 4 times as big. And that means the volume, actually, is going to be scaled up by a factor of 2 to the third, which is 8. So the volume will actually be 8 times as big. So that's just kind of an example of why this works. And if you think about it, it actually makes quite a bit of sense because one-dimensional are edges, right? We just represent the side length of an edge by S or L. Let's call it L. But the area, well, the area is going to be length times width. For a cube, that would just be L times L. So it kind of makes sense that we're squaring the factor because not only are we accounting for this edge, this first length that's been scaled up, but we're also accounting for this second edge that's also been scaled up. And similarly, volume is L times L times L. So that's why we're scaling the volume up by a factor of n to the third. So I hope this made sense to you, and it's a nice trick to use in questions like these.